So in this problem, they're giving us a graph. We know that the graph is v of t, and they're asking us to predict the graph of s of t. And to do so, they're giving us a series of steps in order to predict the graph. So we know that the derivative of s is equal to v. We also know that s of t is equal to the antiderivative of v of t. So we know that the graph that we're gonna graph there of s of t is gonna be the antiderivative graph of a of t. They're also giving us that the starting point of s of t is 0.5. We know that this is a quadratic function, and they're giving us the area of a1 and a2. a1 equals to 7/6 and a2 equals to 8/3. So this is a1 and this is a2. So for the first problem, they're asking us to determine what is the value of s of 1, s of 3, s of 5, and s of 6. So now, for right now, we know that s of 0 is equal to 0.5 or 1/2. So that we know that that's our starting point. So in order to get the value of s of 1, we need to the value of s of 0, we're gonna add the integral from 0 to 1 of s of t dt. So we know that a1 is the area from 0 to 1. So we're just gonna add the value of 7/6. So s1 is gonna equal to 1/2, which is the value of s1, plus 7/6, which is gonna be s over 1 is gonna equal to 10/6 or 5/3. Now that we have what s of 1 is, we can go ahead and calculate how much is s of 3 using the same procedure, but now using this one because this embarks all this part of the function. So to calculate s of 3, we're gonna grab the value of s of 1 and we're gonna add it to the integral from 1 to 3 of s of vt, which is the graph that they're giving us. If we change the values, we know that s of 1 is 5/3 plus the area of 3 to 1 is 8 minus 8/3. It's gonna be equal to -1. So that's our value of s of 3. And now we're gonna repeat the whole procedure for the other ones. So to calculate s of 5, we're gonna, to the value of s of 3, we're gonna add the integral of v of t dt from 3 to 5, which is, since this is symmetric, we know that this is also equal to a of 2. So what we are gonna do is is that S of 5 is equal to -1 minus plus minus, because it's a negative area, 8/3, which is gonna equal to S of 5 is gonna equal to -11/3. So, and lastly, to calculate the value of S of 6, we're gonna add to the area of S of 5 plus the value of the integral from 5 to 6 of v of t dt, which we know that S of 5 is equal to -11/3 plus, we notice that here S of t is the same value of a of 1, and it's positive because it's in the positive side. So it's gonna be equal, we're gonna add 7/6, which give us the value of S of 6 is gonna equal to -15/6, which is also equal to -5/2. So now we have all the values that are telling us to find. So now we know that S of 0 is equal to 1/2. We know that S of 1 is equal to 5/3. S of 3 is equal to 1, -1. S of 5 is equal to -11/3. And S of 6 is equal to -5/2. So we know that in the graph we have those points on the graph of S of t, which is the antiderivative of v of t. So after this, they're asking us to, after finding these points, they're asking us to analyze the graph of v of t, which is in my computer. So in the first problem, they're asking us that on one interval is S increasing according to v of t, and in which one S is decreasing. So for this, we always have to remember that when the graph of v of t is above the x-axis, the graph is increasing. And when it's below the x-axis, the graph is decreasing. So we know that from 0 to 1, the graph of S of t is increasing. And from 1 to 5, the graph of S of t is decreasing, and then increases again from 5 to 6. And then they're asking us to say that on one interval S is concave up and on one is concave down. So for this, if we know here's increasing and then the increasing, we know that the x-intercept is a maximum or minimum. We have one in 1 and another one in 5. So since we know that here is increasing, first is increasing and then becomes decreasing, we know that in 1 is going to be concave down because it's increasing and then it's decreasing. And from here it's decreasing. So it's decreasing, and then in 5 it shapes it and starts increasing. So we know that in 5 we have a concave up, down. So in conclusion, in 1 we have a concave up, and in down we have a concave down. So now they're asking us to predict how the graph looks. So according to the points that we know, we know that it starts in point 5. So the graph is going to start here, and we know that at 1 it's going to have a concave up, and then it's going to decrease, it's going to decrease, and at 5 we're gonna have a concave down. It's gonna increase again. So this is a prediction how the graph is gonna look like. Because here we know there's concave up and then concave down and start at 0.5. And then we know that our one is 5/3. Y is 5/3, and here we know that at 5 it is negative 11/3. For the last part, which is E, they're giving us to find the formula of the graph of S of t. They're providing us the equation of this graph. So if v of t equals to -2 plus 1/2 t minus 3 squared, and we know that S of t is equal to the integral of v of t dt. So we're just gonna find the antiderivative of all this function. So it's gonna be equal to -2 plus 1/2 times t minus 3 squared. So in order to make it more easier to solve, we're gonna split this integral into two. So first we're gonna have the antiderivative of -2 dt plus 1/2 times the antiderivative of t minus 3 squared dt. So now we can solve. So from here it's gonna be -2t plus 1/2 the value of this one. If we expand it, it's gonna be t squared minus 6t plus 9 dt, which is also gonna equal to -2t plus 1/2 times t to the cube divided by 3 minus 6t squared divided by 2 plus 9t plus c. But we can simplify it more so it looks more neat. So this is gonna look like -2t plus t cubed to the 6 minus 3t squared divided by 2 plus 9t halves plus c. Notice that this cancels with this, so our final result is going to look like this: t cubed divided by 3 minus 3t squared divided by 2 plus 5t divided by 2 plus c, which we know, since we know that it starts on 0.5, our c's value is going to be 1/2. So we know that this is the equation of the graph of S of t. So now I already graphed the function on Desmos to prove that our result is right. So here instead of t I use x so I can graph it. And I also plugged in all the points that we calculated with the integral, and we can notice that this equation passed through all of them, and we also have a concave up and 1, and we have a concave down on 5. Thank you.